Good afternoon. I am Mrinmoy Sen from Computer Science and Engineering Department in Haldia Institute of Technology, and today I am going to discuss on the topic Introduction to Design and Analysis of Algorithms. And here is the introductory part, that is here where we will discuss what an algorithm is, and basically what we know, an algorithm is nothing but some logical steps towards solution for a given problem. And if we think before programming, algorithm come first, that is algorithm comes in designing phase, and algorithm is the textual representation of the logics behind the concept. And before algorithm, if we think about the pictorial representation, then flowchart is there. So flowchart first, then algorithm, then programming. And here we are having some conventional definitions regarding the algorithm. What we can say, algorithm is the step-by-step procedure towards solution of a given problem. And here you will find another definition of algorithm. Algorithm is a set of operations to solve a problem performing calculations, data processing and automated reasoning task. So in a single sentence we can say an algorithm is an efficient method that can be expressed within finite amount of time and space. So time and space do matter here in case of algorithm. That is, once we are starting an algorithm, the logic starts, so there must be an end. So in between we are having some execution, and where we will follow the logic to reach the output. And the introductory part continued. The most important aspects of algorithm design includes creating an efficient algorithm to solve a problem in an efficient way using minimum time and space. So earlier we have talked about the time and space, these two criteria, and that is, there is no enormous time and huge space to solve a particular problem. If we are eager to solve a particular problem, then we must finish the execution of that problem within a time bound and within a space bound as well. That is, as much as efficient will be in case of time and space, the algorithm will be more efficient. To solve a problem, different approaches can be followed. Some of them can be efficient with respect to time consumption, whereas other approaches may be memory efficient. So we can achieve the efficiency in two ways, either in terms of time, either in terms of memory. And when we are considering the time, maybe the logic or the program, it will contain less amount of memory, so that the execution time will be less, and more the space an algorithm or program will occupy, so it will take more time to execute, and hence it leads to a lesser efficient algorithm or programming approach. And here we are going to discuss about the properties of algorithm. And to evaluate an algorithm, we have to satisfy the following criteria. These criteria include input, output, finiteness, definiteness and effectiveness. And as we know, we are doing this designing phase, that is, we are building this logic, building this algorithm towards solving the problem. So there must be a starting point where we are providing all the inputs, and there must be an ending point where we are deriving our desired output. And in between we have to validate the algorithm, or we have to check the efficiency of the algorithm, and before that we have to check the finiteness of the algorithm. Finiteness means once it is started, there must be an end, and our execution must be finished within that stipulated time period. So the first point which we will consider here is input. The algorithm should be given 0 or more input, and output at least one quantity is produced. That is, toward the solution we will generate at least one output, and there may be a situation, that is, we may have more than one outputs. That is, in case of say some interactive approach, we may have in different time slots, we may have number of outputs for a particular given task. And definiteness, so it is instruction, it is telling about the instruction is clear and unambiguous. That is the same example I would like to mention here. That is, we are having two inputs 2, 2, and we have to generate the output 4. That is, if we don't mention the operation, that is what operation we are going to perform explicitly, then the problem is still ambiguous. That is, what is the ambiguity? Ambiguity is that how we have produced the output, that is what operation we have chosen. That is either addition or multiplication, because 2 plus 2 it constitute 4. 2 multiplication, that is 2 multiplied by 2, it also results in 4. So that's why, as both the inputs are 2 here, so no different in the outcome. That is either in case of addition, either in case of multiplication. But whenever we will change the operators, then the outputs also will vary. That is, in case of addition or multiplication, you will see that is in place of 2, 2, if we give the another set of inputs, then it results in some different outputs. And finiteness, it is telling about the limited time period, that is with which you have to finish your execution, and no enormous time will be given to the end of the day. That is, you are not having the entire day or entire year or entire month to finish a particular calculation. And what about the effectiveness? Effectiveness is every instruction must very basic, so that it can be carried out in principle by a person using only pencil and paper. And it is telling about that the understandability, that is the logic behind it, it should be understood by all the persons. And that is, the implementation is something different. What we used to do in case of a programming, that is the person should have the knowledge in programming, that is a particular programming language, the semantics, syntax, all those things. But the logic is common for all. That is, you may use the different platforms, but logic will be same for the all platforms. And some more words on algorithm. A well-defined computational procedure that takes some value or set of values as input and produces some value or set of values at output. And written in it can be written in a pseudocode which can be implemented in the language of programming or programmer's choice. That is, either the algorithm can be converted to its corresponding pseudocode or through a programming language for the implementation phase. And what a pseudocode is? It is a notation resembling a simplified programming language used in program design. So we can use the high level language, that is English like language, or we can use the pseudocode when we are writing an algorithm. That is, all those steps we are following, that should be in sequence. And how to write an algorithm? Here we are having two instances. That is, with the first instance, we can see the left side instance, it is showing the pseudocode presentation. And here we are trying to find out the greatest of three given numbers. And here the starting point is there, and we are considering the inputs A, B, C. Then the computation is performed. That is where we are comparing all the variables, three variables, and finally we are getting the greatest value. That is, at each and every step we can find the greatest value. That is, if you follow for the step 3, if you consider first two statement, then we can generate an output at line 3 for step 3. And again the procedure is continued, and after each and every 2 statements you can provide the result, that is either A or B or C, and finally it is the stop is there, that is which is indicating the finiteness of this algorithm. The similar logic is followed here, that is where we have tried to present the same logic with conventional programming language, that is start point is there, A, B, C, all these 3 are the inputs. Then we are comparing the variables to generate the greatest of 3, and here the steps we have here, that is 6 number of steps, and it is clear from these 2 approaches, that is which one is better. The first one is stating the same logic with the minimum number of steps. If you count the number of steps for the first one, that is the left side, there are altogether 4 steps, 1, 2, 3, 4, whereas the same logic is presented using another approach, which is following the more number of steps, 1, 2, 3, 4, 5, 6. So it is clear that is which one will be more efficient. Obviously the left side, the logic which is stated at the left side, because here it is having the lesser number of steps which will be executed faster, and it will be taking the lesser memory space as well. So in terms of space complexity and time complexity, we are benefited following the left side approach. And here we are going to state the differences of algorithm and program. And as we know, program is nothing but the set of instruction. There is an instruction is responsible to execute a particular tiny task. That is, whatever task we are provided, that can be divided into number of tiny tasks. That is, if we compare or if we make an analogy, we can say that is a tiny task is matched with the threads. A program may have multiple number of threads, so each of the task is a thread, and each of the thread can be executed with the micro instructions as well. And here we are going to differentiate the algorithm and program. So first of all, we are having the 4 points against each of them. So algorithm is followed at the designing phase, and in contrast the program concept, it is followed in the implementation phase. And if you compare the step 2 or point 2, there you will find it is generally in case of programming, the programming language is followed to represent, and in case of algorithm we are having any natural language. That is, we have stated earlier, that is pseudocode is there, we are having the English like high level language is there, so which is natural language. Point number 3, the person who is designing at the designing phase, the logic, who is designing the logic, so that person should have the enough domain knowledge, because the designing phase is more, or I like to say most important when we are going for the programming part. So designing first, then implementation. The programming is actually the implementation part. So the person who is designing the algorithm, the person should have the enough domain knowledge. And whereas in case of program, the only programmer can do the rest of the task. That is, only the programmer should have the knowledge about a particular language. The person should know about the syntax and semantics of that particular language, and the person is capable enough to do the rest. For the 4th point, here with the program we generally used to do the testing part. That is what we are going to perform. That is whether we are getting our desired result. We are providing inputs and we are expecting the outputs. So we will check whether we are getting the output, desired output. And whereas in case of algorithm, we are mainly analyzing. Actually, what we are analyzing? We are analyzing, that is, how much efficient the algorithm is in terms of space and time. That is, time complexity and space complexity we are judging there. and here are some specifications of the algorithm, and I think all these points we have already mentioned. That is the natural language or English like language. An algorithm is written either in any natural language or in English like language, which is preferably known as high level language. And when this way is chosen, care should be taken. We should ensure that each and every statement is definite. That is, no ambiguity should be there. The logic should be clear, and which will be understood by any common people. And another thing is the graphical representation. So I have mentioned as well, which is flowchart. So flowchart comes first, then algorithm. Algorithm is nothing but the same logic is presented in textual representation, whereas flowchart is pictorial representation. And here we will mention the pseudocode method once again, already discussed, and the programming language. The programming language is used at the implementation phase, that is when from algorithm you are writing the programming, and it is mainly the programmers are there who are efficient enough to use this programming language to convert an algorithm to its corresponding program. And issues related to the study of algorithms are how to create an algorithm, how to validate an algorithm, how to analyze them, and how to test a program. For point number 1, that is how to create an algorithm, we are having number of options, because based on the problems provided we are having different approaches. That is, if we consider about the merge sort, then definitely we will follow the divide and conquer approach. So which is nothing but the, in case of divide, basically merge sort is nothing but the joining the two sorted arrays, and where the all the resultant array should have all the elements in sorted order. Again, to that end we are dividing both the sorted arrays. And how long this process will be continued? Until or unless we are getting all the sub arrays which is which contains only single element, because after that no more division is possible. And once we have reached that state, then now it is quite, the task is easy. So till now whatever we have done, it is all about the division. So that's why the term is coming divide, and rest part is conquer. Conquer means building again. There we will be considering the two sub arrays to merge it to constitute the resultant arrays, where the all the elements will be sorted again, and that process is continued until or unless we used to get the final sorted array, which is our desired output. So that is all about the divide and conquer method. And here greedy method is there. Greedy method is telling about the local optima. That is when we are finding the best solution for a particular problem, then we will see that is what is the best solution here for a particular domain. As an example, we can say in a classroom, when we are considering a particular boy or girl who is ranked first, that is true in case of that class only, because when we will see for other classes, we may find another boy or another girl whose result is far better than the boy or girl in the particular class we have mentioned earlier. So there the global optima is something different, local optima is something different. Local optima is always telling about the best solution for a particular domain. So we have to consider all the local optima and we have to compare them, then we can find the best solution for a particular given problem. So that is that approach is followed in case of greedy method. And in case of dynamic programming, basically we used to divide the program into sub problems. Then we are storing executing those sub problems, we are storing the result, and later on when we will face the similar kind of problem, then we will use the stored values for those sub problems, that is the solutions of those sub problems, and we can proceed further. That is the concept of dynamic programming. In case of branch and bound, So as the name suggests, the branch and bound is the problems are having some branching, and there is some limitations as well. And once you are reach following a particular branch, if you find the solution there, then it's fine, otherwise you have to stop there, you have to follow the alternate branch. And in case of backtracking, it is also can be represented with a tree structure, and which used to follow the top down approach. And here all the paths or routes we are having, so which leads to the leaf nodes. So each of the leaf node is actually nothing but the solution for our given problem. And if you can't follow the particular path, then you have to have the backtrack to its parent node, so that you can follow the alternate path to reach an alternate target or alternate solution. And here, how to validate an algorithm. Once an algorithm is created, it is necessary to show that it computes the correct output. So not only the designing is sufficient, and after the that is when the algorithm is designed, then you have to validate the algorithm whether it is producing the correct result. So the earlier example we have mentioned, that is in case of 2 and 2 constitute 4, if you don't mention the operation clearly, that is whether you are performing addition or multiplication, then there will be an ambiguity. What is the ambiguity? That is just change the operands. That is, in place of 2 and 2, you provide 2 and 3. So in case of addition, it will generate the result 5. In case of multiplication, it will generate the result 6. So this is the validation. That is whether you have used the correct operator there or correct operation there. So not only designing is enough. So after the algorithm is designed, you have to validate it as well. And how to analyze an algorithm? So analysis is again regarding the computation time and the storage space. So we have mentioned several times regarding the space complexity and time complexity. Nowadays space doesn't matter, or time does matter, because our ultimate goal is to reduce the time and to execute the any given problem faster. That is, if the time complexity is reduced, then there is some sort of achievement or development. And how to test the program? The program is nothing but an expression for the algorithm using any programming language. To test a program, we need the following. So we are having mainly two phases, debugging and profiling. Debugging is nothing but you have to check for the further correction. That is, it is processes of executing programs on sample data sets to determine whether faulty results occur, and if so, correct them. So every time you are having a set of data and you have to provide them to your system. If you are getting correct results, then it is okay, fine. Otherwise, you find out the faulty parts of your coding, and not coding I will say right now, because still we are in the designing page. So rather we will say algorithm. So you find the error in your algorithm and correct it. And profiling is the study about the space and time complexity. That is, how much space is required and how much time is required for the execution of your program or algorithm. And here the analysis part is done either before the execution and after the execution, or after the designing of the algorithm. So we are having the two part, priori and post priori. And this priori part is done, that is when you are running the algorithm on a specific system, because it is all about the dry run. Still it is not implemented, still the program is not there, you are not using any platform, not using any programming language, so only you are running. So it is known as dry run. So, and in contrast, we are analyzing after running on a system, that is when it is implemented, the algorithm is implemented, program is there, you run it on a system, that is post priori. And when you are at the designing phase, that is at the very beginning stage, logical stage, then it is hardware dependent. And when once you are going to implement, that will be hardware dependent, because the instruction set is designed based on the architecture you are having for a particular system. So that's why we know that in case of instruction set, we are having the CISC, we are having RISC, where CISC stands for complex instruction set computer, RISC stands for reduced instruction set computer, and it all depends on the hardware architecture, because you are more the complex hardware you are having. So with the lesser number of instruction, you can execute a particular problem with lesser time. And whereas for a simple architecture, you may need the more number of instruction, because the simple architecture, it used to perform the very teeny task at a particular given time. So as you are performing very teeny task, so it will take more time, or it demands more instruction to be executed to complete the particular given task. The third one is approximate analysis. So to the end of this approximate analysis, we are having either best case, we are having either worst case, we are having either average case. That is, with the best case, we can see the time required will be the less, or we can say the minimum time. With the worst case, the maximum time is required, whereas in case of average case, the time will be there, that is, a stipulated time range will be there, and within that stipulated time range, you have to have complete the execution of your program. And whereas the after implementation part, when you are executing your program, then you will get the actual statistics of your algorithm, that is what you have expected, what is your approximation, and what is the practical, or what is the actual. So that thing you can find after implementation part, which is post priori. And in case of priori, it is dependent on no number of time a statement are executed. That is, if any loop is there, any repetitive task is there, so the execution time also will be more. And they do not do post priori analysis. Actually, this kind of feature is not available with the post priori analysis, so we are not going to consider this statement here in case of post priori. And here are the needs of the algorithm. So till now we have discussed many points, so just have a look to understand the basic idea of the problem, to find the approach to solve the problem, to improve the efficiency, and with the compared to existing techniques, and how we can claim our one is more efficient or more developed, definitely in terms of time complexity and space complexity. If the earlier program which demands more time or more space, and your one is comparatively occupying less memory space, or it is having the lesser execution time, definitely you can claim your one is better than that of the earlier one. And to understand the basic principles of designing the algorithms, to compare the performance of the algorithms with respect to other techniques. It is the best method of description without describing the implementation detail. That is, all these things are post priori. That is, before implementation part, you can have a dry run, that is following the number of steps you are following the loops you are using there, all those things. The algorithm gives a clear description of requirements and goal of the problem to the designer. So that's why we have mentioned that designer should have the expertise, domain knowledge on this particular problem or given task. And a good design can produce a good solution. So it is obvious. So based on the constraint we have considered till now, so it is very much clear that as you are taking care of those constraints, that is in case of time, in case of space, in case of the other designing aspects, that is the number of loops you are using and all the data structure you are using. So all those things will be very much clear. And finally, to understand the flow of the problem. So flow of the problem, it definitely follow the number of steps one is following when the person is writing the logics or techniques step wise. And here is a glimpse of performance analysis, and there again we can perform either space complexity performance or time complexity performance, and later on we will see both space and time that can be judged in terms of the fixed space complexity or variable space complexity, what we used to term as the linear complexity. So in case of both space as well as in case of time. So which is mentioned here. Now there are two types of space complexity, that is fixed, which is constant space complexity, and linear or variable, and how they appeared. So now we are going to discuss about that with an example. In case of constant space complexity, so as the example is set here, that is simply we are performing the square of a particular number. So now here the number is a, and which is variable. So whatever the value we will consider against the particular variable a, so there will be no change in terms of space, because if a is integer, definitely it will take 2 bytes. So there is no change, it is fixed. That's why the term constant space complexity. In contrast, we are having linear space complexity as well, where it is mentioned that size of the variable, if it is n, then it will consider one word. Array of a value, so as we are considering n number of elements in the array, so each of the element, if we consider they are occupying one word, so for n number of variables we will have n word. For loop variable, that is say for I equals to 1 to I, range, maximum range is n, and whatever the increment or decrement operation we are performing there. So I variable, so we are having another word count. And now sum variable, if we are going to calculate the sum of a range of the variable, then for the sum variable we have to consider another word count. So if we consider this example, that is we are writing a function sum where the array is there, and as a parameter we have passed here, and integer n parameter we have passed here. So for the array, as we are considering n number of elements there, so word n word is required. For the sum we are considering another one, for the I we are considering another one, for sum we are considering another one. So and we are returning the sum value. So here we are calculating, that is how much space complexity. Here 1 plus n plus 1 plus 1, so altogether n plus 3 words. Now time complexity. So here also, for when you are designing an algorithm, for algorithm heading, so no word is counted. For braces, no word is counted. For expressions, only one word is counted. And for any looping statement, number of times the loop is repeating, so that is counted. And when we will consider the example, that is, here is the example for constant time complexity and for the linear time complexity. At first let's consider this constant time complexity. Here we are having the function sum, and we have considered two variable a and b, and simply we are returning a plus b. So that's why it is constant, because no repetition is there. So only one time we are calculating a plus b, that is returned. In contrast, if you consider linear time complexity, so as we have mentioned earlier, for comments no word count will be there. For assignment statement, only one word count. For condition statement, one count, word count. For loop, n plus 1 steps, and for body of the loop, n steps. That is how many times we are going to, how many iterations we are considering, that is n. and with the example you can find, and the brace is missed here. Anyway, the sum I for I equals to 0, I less than n, I plus plus sum a plus I return sum. So count will be again n plus 3, because here is n 1 1 and 1. So n plus 3 is the count here, word count. And kinds of analysis, that is we are talking about the design analysis of algorithm. So here is the analytical part, and basically we will be considering the worst case, average case and best case. Worst case, it is usually, that is it is all the time it is expected. It is the maximum time of algorithm on any input of size n. And average case is the expected time of the algorithm over all input size of n. And best case, it is the minimum time. And if we take an example, that is when you are searching a row, and if you are finding the student, and if you find the student at the very first position, then it is the minimum time, so that will be the best case. If you are searching the entire row and you can find the student at the end, then that is the worst case. Or the another possibility is there, that is the student is not there in the row. So you have searched the entire row, but still you couldn't find the student there. And in that, this is the normal case. Sometimes there is expected time. So with this, I would like to end my speech. Thank you.